Alright, so while I'm waiting to see if anybody shows up for our help session, thought I'd just try to record this video for us for next week. So we're going to be looking at the factor theorem next week. So what does it mean if something is a factor of something else? Well, for instance, if we consider 12 as an integer, what are some factors of 12? Well, factors of 12 could be 1 and 12. It could be -1 and -12. It could be 2 and 6. It could be -2 and -6. It could be 3 and 4. It could be -3 and -4. Which means that if they are factors, if I were to divide 12 by any of these integers, I would get another integer. That's what it means to have a factors. Factors mean when you divide, there's no remainder. So it's important to keep that in mind as we talk about what factors are, as far as our polynomials go. We're doing the same thing. We've opted not to put in the long division portion because we figure we can go without it, and it's kind of tricky and I don't want to just do it over a video. So we're just going to leave it as the factor theorem. So let's take a look at what the factor theorem is. The factor theorem says that if we have a polynomial f of x and a number c is a solution to f of x, that means that happens if and only if x minus c is a factor. So for instance, what this is actually saying is that if we plugged in f of c, it would equal 0. So if f of c equals 0, that means that when x equals 0, or when x equals c, that's a solution. If that's a solution, if we work backwards by subtracting c from both sides, then that's going to tell us that x minus c had to be a factor. So let's look at a couple of other things that are told to us by this simple statement. The first thing is the factor solution interception equivalence theorem. All of these are the same thing. They all mean the same as if we have a factor here. So if c is a factor, that means that f of c equals 0. That means that x equals c is a solution. Okay? And it means that x minus c equals 0 is a factor. Okay, so as we're looking at that, so one of the things that we have down here is x minus c is a factor. Why? Because if x minus c is a factor, that means we're going to solve it and we'll have it factored into x minus c equals 0, so x equals c would be our solution. F of c equals 0, because if we plug c in, that should equal 0. So that tells me I can tell if something's a factor by substituting it in. And if my solution, when I substitute it in or evaluate, equals 0, then I know I have a factor. C is an x-intercept of the graph. Alright, so that means if I were to graph my polynomial, C would be an x-intercept. Okay, and C is a 0 of f. 0 and x-intercept mean the same thing. And so that means that the remainder is also 0. Because if something is a factor, that means its remainder is 0. So given all of this information, what does this allow us to do? Well, take a look here. Let me just change these colors so we know that this was added during our lesson for today. I don't want it to blend in with the other backgrounds. Okay, so let's take a look at this particular example. Here we have the example x to the 4th minus 6x cubed minus 4x squared plus 24x. And the directions say to factor. Okay, so what I'm going to do is I'm going to use my tools. And I'm going to go to Desmos. So I came over here to Desmos and I typed in the equation that I had from my flip chart said x to the 4th minus 6x to the 3rd minus 4x squared plus 24x. And I come over here and I've got these graphs. Now, based on that factor theorem, the factor theorem says that whatever my zeros are, I can use those to write my factors. So if I remember on here, when I highlight that function, I can identify my zeros. So I have a 0 at -2. I have a 0 at 0. I have a 0 at +2. And I have a 0 at 6. So when I'm going to come back over here, I had 2, 0, -2, and 6. So I know that I have solutions at -2, 0, 2, and 6. Now, since those are my solutions, my factor theorem says if C is an x-intercept of the graph, then C is a 0, so that means the remainder when it's divided by this factor is 0. So there's my factor. So I'm just going to kind of work backwards. So basically it's like saying x equals -2. Well, if that's x equals -2, above that it said x plus 2. True? And here it says x equals 0, so above that it said x plus 0, or just x. Here it says x equals +2, so above that it had x minus 2. Here it says x equals 6, so above that the factor was x minus 6. Now, we don't normally write x plus 0, so if we wanted to write this as a final answer type problem, we'd have our x, and then x plus 2, and then x minus 2, and then x minus 6. So that's a pretty straightforward way to factor. Okay? Now, that was easy because our factors, or our solutions, were integers. All of these were integers, and so that made it super nice. It's not like they were ugly square roots or ugly decimals, but that's not a problem because we can always turn those into fractions. But this is a nice, easy way to factor, and then because we knew the factor theorem, since those were zeros, bam. Now what that means is, if x equals 0, if I plug in 0, that all equals 0. If x equals -2, so if I put in the opposite here, -2, it should equal 0. And I can check that on Desmos, because I can go back here into my settings and I can show the table, and I can see at -2 it's 0. At 2 it's 0. I'm sorry, at 0 it's 0. At 2 it's 0. And then I can look at my next one and say 6, and I can see that that's 0. So it verified it by substituting it in. One moment. Okay, so we got that one. So now what we're given is we're asked to find an equation for this third degree polynomial, and we have the graphs here. We don't have the equations, but we have the graph, so we can find our x-intercepts. So this x-intercept looks like it's here. This one looks like it's here. This one looks like it's here. So if you had to estimate what these would be, maybe it would be x equals -5. Maybe it would be x equals -3. Then maybe it would be x equals 2. So then to find our equation, if these are the solutions, that means that x plus 5 is the factor, and x plus 3 is the factor, and x minus 2 is the factor. So I think it's x plus 5, I think it's x plus 3, and I think it's x minus 2. So now here's a beautiful thing you can do. You can open up your Desmos, and you can go back. I'm going to take out that equation, and I'm going to type in my new equation, which says y equals x plus 5, x plus 5, and x plus 3, and x minus 2. Oh, and I put minus, didn't I? Equals. And then if I make this window match the window that was here, it went from -80 to 100. So I can go back here and set my window from -80 100. And my x went from -8 to 8. And so then I can look at this window, and does this match what I see over here? Sure does. Sure does. So bam. And then one more problem. So it says to find a third-degree polynomial with integers coefficients. So these are our zeros. So we know that one of the zeros is x equals 1. We know one of the zeros is x equals 3/5. And we know one of the zeros is x equals -2/3. Now the last ones we've had have been really easy to work backwards. True? So what we would do here is we would just subtract 1, so this would be x minus 1. So that was our factor. Here, we're not just going to subtract 3/5. We're going to multiply by 5 first. So 5x equals 3, because that's how we got to that 3/5. So then we're going to subtract 3. So 5x minus 3 is going to give us our solution. So that would be our second factor. And then here we would multiply by 3 and add 2. So that means our factors for this polynomial would be x minus 1, would be 5x minus 3, and would be 3x plus 2. Now, it could be that if we were in using this in our textbook at school, that we would say, hey, multiply those together so that you can expand them. That's an Algebra 1 skill. If you can't multiply those together, then you should probably come see me in one of the help sessions. If you can't multiply them together, if you can multiply them together, great, do it. I'm not going to because I don't have enough space left here, but that would be my polynomial degree 3. How do I know it's degree 3? X to the first, x to the first, x to the first. So when I multiply these two, I'd get x squared, but I'd have to take that x squared times this, which would give me an x to the third. Okay? So that's our polynomials factor theorem. Make sure that you complete the assignments that are on It's Learning.